Okay, wonderful. All right, so given a random variable x, which is normally distributed with a mean of 15, the standard deviation, find px less than 20, px greater than 12, px between 12 and 20. So first things first, since we've seen the letter x here, it's dealing with a normal distribution, so we have to standardize it first. Right. Who remembers the formula to standardize? Yes, x over mean divided by standard deviation. Okay, so we start with part A. Our x value is 20. Our mean 15. Standard deviation 10. 20 minus 15, that is 5. 5 divided by 10, that is 0.5. So this transforms to p z less than 0.5. Okay, our x has become a z, meaning it's been standardized, and this 20 becomes this 0.5. So as we can see, the sign is pointing to the left, and we're using the area to the left tab. Okay, so in this case, it's just a matter of reading from our table. Okay, since the sign is pointing to the left, this side, so it's representing this blue area here. Okay, so our value is 0.5. Colleagues, how do we read our value from the table? Mhm. Yes, for the first two digits, this is 0.5. We're going to find it in this column, yes, and it's here. Hmm. We go to the row, this row here, the top row. Yes, for the last number. Yes, and so our value is where these two intersect, right? Yes. So the value here is 0.6915, which can be represented as 69.15%. But you can just leave your answer like this, 0.6915, Any questions? Yes. This sign, this less than sign here. Yeah. I shouldn't have said arrow. It's actually a sign. Uh-huh. Oh, okay. It was we pressed it again. Okay, we go to the next one. Px greater than 12. So first things first, we need to standardize. So colleagues, let's standardize using the formula. Let's see what values we get. X, so x minus the mean divided by the standard deviation. So the mean, x is 12, the mean is 15, standard deviation is 10. 12 minus 5, that is negative 3, divided by 10, we get negative 0.3. So this becomes P Z greater than negative 0.3. So we can see our sign is pointing to the right. Okay. And we are using area to the left table. Okay, since our value is negative, so we come to this negative one here. Okay. Yes. So basically, what we're looking for is this white area here. Okay. Now, since we're using the area to the left table, the only area that we can get at the moment is this area here. Okay. So the way we get our white area, okay, is the probability of the blue area plus the probability of the white area equals 1. Okay. Probability of this blue area plus the probability of this white area here, when you add them together, they have to equal 1. Okay. So the blue area is represented by P Z less than negative 0.3. And when you add it with PZ greater than negative 0.3, you're going to get 1. Any questions? Mm-hmm. Mhm. No, 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 no. We only do this when this sign is pointing to the right, and we're using this kind of table. Okay, when the sign is pointing to the right like this, and you're using this kind of table which is giving you the area to the left, that's when you're going to use this. Sometimes the negative values can be can the sign can be pointing to the left. So the negative value, we can just still read it here. Okay. So we only do this when this sign points to the right, and we're using this kind of temp where the shaded area is to the left. Are we okay with that, sir? Yes. Uh-huh. I heard another hand get raised. Mm-hmm. Mm-hmm. There's greater than, yes, there's greater than and less than. The base the all right. Finish up. Yes, you're correct on that one, sir. Continue. The, okay, okay. The less than sign is representing this blue area. Here the concept is this. Okay, when you add the blue area plus the white area, you get one. Remember, probabilities always add up to one. So this area in blue, okay, since our Z we calculated it as negative 0.3. Okay. So this area in blue, okay, if you think of this as a number line, this area in blue is less than negative 0.3. Then this area in white is greater than negative 0.3. Yes. So just remember, colleagues, when the sign points to the right and you're using area to the left table, you're going to always have to do this. Okay. Yes. So we come to our table, we read our, oh, before we come to read our values, any other question? Yes. From our table, yes, someone to tell us how we read this? Mhm. Yes, this is the value. So the first two numbers 0.3 in the column. Then the last number is 0. So you come to this row, the first in that row. And then when you intersect, you get 0.3821. So here, you can put it like this: 0.3821 plus the probability. Let me just admit it based on it. Plus the probability that Z is greater than negative zero point 0.3 equals 1. So in order to find the probability that Z is greater than negative zero point 0.3, we take this 0.3821 over the equal sign, and it becomes 1 minus 0.3821. 1 minus 0.3821, 0.691. No, okay, okay. 619. Yes. So that is our answer here. 0.619. Yes. Any questions before we move to the last part? Oh, and yes, you need to show these workings in your calculations. You need to show this, then that. So just remember here it's less than plus greater than equals 1. Then whatever probability you have, I mean, whatever Z score you have, you just put it there. Any other questions? Sometimes it depends the way it's printed. Sometimes sometimes you won't see this diagram here. Okay, sometimes there'll be a diagram. So if there's a diagram, well and good. If there's no diagram, this is an easy thing to draw. All right. But the table will be labeled. So if it says area to the left, then you know, okay, let me draw this diagram and shade my left area. If working with these diagrams helps. But once you get the hang of it, you won't need the diagrams. Okay, we go to part C, where you have the value between x between two values, p 12 less than x less than 20. Okay. So we standardize this. 12 is negative 0.3. 20 is 0.5. All right. So always remember this. Whenever you have x between the two values, it's the greater probability minus the lesser probability. Okay, greater probability minus the lesser probability. Okay. Since 0.5 is greater than negative 0.3, so this one has the greater probability. So this becomes P Z. Oh, this here is it was supposed to be. Yes, PZ less than 0.5 minus PZ less than negative 0.3. Okay. When the letter is between two values, it's the greater probability minus the lesser probability. So usually the number at the right side is the greater one, the one at the left side is the smaller one. Okay. And then you maintain one sign. Okay. Notice here, we have maintained only one sign, the less than sign. Okay. As you can see here, it's going through less than. So you maintain the less than sign. Okay. Now, we already have these probabilities. PZ less than 0.5, here 0.6915, minus PZ less than negative 0.3, here, which the one we got here, Z less than negative 0.3, 0.3821. Okay. Notice we're using this one with the less than sign, not this one with the greater than sign, the one with the less than sign. Then you just subtract 0.6915 minus 0.3821. Ish, this time people are having bad network. Huh? Fog. Huh? Okay, okay, fog, yes. Any questions? So when it's between, the letter is between two numbers, just remember greater probability minus the lesser probability. Okay, the bigger number will have the greater probability. So you put it in front. Okay. Remember, with probabilities, you're never supposed to get a negative number. Okay. A negative number or a number above one.